Hi, this is Mrs. Boland with your 11.1 review assignment. So we are on page 109 of your workbook, and we are factoring out a greatest common factor. So remember, if you watched my video for the 11.1 lesson, I have two secret shortcuts. Number one is check the smallest number and see if it goes into both of them. So the smallest number here is 9. Can 9 also go into 45? Yes, it can. You can use the multiplication chart on the back of your workbook to check that if you weren't really sure. So I'm going to be pulling out a 9. Then I want to also check for x's. Do they have any x's in common? This has 1. This one doesn't have any. So I can't pull out the x's. I'm just dividing out the 9. So we want to put what's left. So if I'm pulling out the 9, all I have left is the x. And then 45 divided by 9 is 5. So that's going to stay on the inside. That's it for number one. For question number 2, again, you're going to check to see the littlest number. Can it go into the biggest one? Yes, it can. So I'm going to put the 7 right there. Then if I have 2 x's in this one and 1 x in that one, I want to know what's the most number of x's I can pull out that they both have in common. I can say, well, they both have 1 x. So that's what they have in common. We're looking for the greatest common factor. So I'm going to put an x out there, and then we're going to put what's left. So I like to just divide by 7x. 7 divided by 7 is 1, which we don't need to write if we still have something else left. I had 2 x's. I pulled out 1, so I still have 1 x left. Well, then 21, negative 21 divided by 7 is a negative 3. If I had 1 x and I pulled it out, there are not any x's left. So that's that. Question number 3, we're going to do all of the problems today. Just since this is a review assignment, I want to go through all of the problems with you guys. Question number 3, I'm going to say, let's check that little number, see if it goes into both of them. Can 6 go into 24? Yes, it can. So I'm going to pull out the 6, and then same thing. If I've got 2 x's and 1 x, then what they have in common is one of them. So I'm going to be dividing by 6x because that's what I'm factoring out. And I want to see what remains after I divide out the 6x. So the 6's cancel. I had 2 of them. I'm taking one of them out, so I still have one of the x's left over on that one. Negative 24 divided by 6 would be negative 4. And then the x's, I had one, but I'm dividing one out, so I don't have any x's left on that one. All right, another one, just like it. So this one, neither one of my secret shortcuts work. Sometimes I check to see, well, can the little one go into the big one? Nope, 14 can't go into 35, so that didn't work. If I subtract them, could that go into it? A difference of 21? No, that couldn't. So you need to say, well, 14 is 2 times 7, and 35 is 5 times 7. So what do they both have in common? They both have a 7. Okay, so 7 is the biggest number that I can pull out. And then if they've got 2 x's and 1 x, the most x's they have in common would be 1. So I'm going to divide by 7x on both of these. And I'm going to put what's left. 14 divided by 7 is 2. I had 2 x's. I'm dividing by one of them, so I've got 1 x left. And then on this one, 35, negative 35 divided by 7 would be negative 5. And then x divided by x, those just cancel out. There's no more x's. And that's what we get. Question number 5. Well, the numbers, I can't pull out any numbers because 5 and 1 just have 1 in common, but it doesn't really help us to pull out a 1. But we could say this one had 2 x's, this one had 1 x, so I can pull an x out. So divide by x, divide by x. Let's see what's left. So I have 5, and then if I had 2 x's and I divided one of them off, I would have 1 x left. Then this one, x divided by x just equals 1. So remember, anytime it cancels and there's nothing left, we know that it goes into itself one time. So you have to at least put the 1 there. For question number 6, we're going to look at both of these. And again, my secret shortcuts don't work. Does the smallest number go into both of them? No. If I subtract them and get 24, does that go into both of them? No. So that didn't work. So we're going to see what other things they have in common. So I'm going to tell you right now it's 4. So if you look at both of those numbers on your multiplication chart and see if there's a row that they both appear in, it's going to be on 4. That's the highest number. 2 would also go into both of them. So sometimes that's what you could do. If it's even, you know 2. If you divide it by 2, can 2 go into it again? Then you know that you can take a 4 out of it. So I'm going to put a 4 and 1x is what they have in common. So if I divide both of these by 4x, we're going to look, and 20 divided by 4 is 5. I had 2 x's. I'm taking out 1, so there's 1 left. 44 divided by 4 is 11, and the x's cancel. All right, moving right along, question number 7. Man, my secret shortcut doesn't work on any of these. So I know that when I subtract, oh, it does, just kidding, it does. I know 12 can't go into 18, but if I subtract them, I get 6. And 6 can go into both of these. So I know that 6 is going to be the biggest thing that I can pull out of both of them. And then if this one has 6 x's and this one has 3 x's, they have 3 of them in common, okay? And that's what we are trying to pull out, the greatest common factor. So what's the most that they both have that I can pull out? Okay, and so then we want to see what's left. 18 divided by 6 is 3. If I had 6 x's and I am dividing off 3 of them, I still have 3 x's that are left there. Because remember, it just subtracts. If you remember back when we were doing the properties of exponents, the reason why we subtract is because for each one that's the same in the top and bottom, we're canceling them. So you want to see how many are left over after I've canceled off 3. Well, you still have 3 left over. And then 12 divided by 6 is 2. I have 3 x's. I'm dividing by 3 x's. Those cancel. I don't have to put a 1 because I already have a 2 there saving the spot. Question number 8. This one, the littlest one, 17, does actually go into 51. It goes in 3 times. So I'm going to pull out the 17. And then if I look, this one has 3 x's. This one has 2. The most x's I can pull out that they both have would be 2 x's. So I'm going to divide by 17x squared, 17x squared, and I'm going to see what's left. So this one would just be 1x. 17 goes into 51 3 times. The x squareds cancel. We just had x plus 3. Okay, question number 9. We are going to look at this one a little bit harder. So if you know your multiplication facts, this one you might look at and be able to say, oh, it's going to be 9. 9 can go into all of those. Okay, we can also subtract the 2 that are closest in value, 27 and 36, and we get 9. So that's another kind of way to tell is the difference in them is probably the biggest thing that can go into both of them. Sometimes the difference is too big and that doesn't work, but that's a good place to start, is find the 2 that are closest and subtract them. So 9 can go into those, and x can go into each of those. And so I'm going to divide each of those by 9x. So on this one, that's 4, 3 x's, take away 1. And remember, we're not taking away, we're canceling one of them. Gives me 2 x's left. And then 9 goes into 63 7 times with 1 x left. And then 9 goes into 27 3 times, and all of the x's canceled off. So that's our final answer on number 9. Question number 10. We are going to look at the numbers, and the littlest number 3 can go into all of those. So I know I can pull out a 3. The most x's that they all share would be 2 of them. And then I'm going to divide by 3x squared on each of those and see what's left. So I know that here the 3's canceled. I have 2 x's left. 3 goes into 15 5 times with 1 x left. And then 3 goes into 9 3 times with no x's left. All of those x's go away. Okay, and that's your answer. Question 11. We can check the lowest number that won't go into them, but then we can check and see the 2 that are closest in value would be the 20 and the 15. The difference there is 5. Can 5 go into all of those? Yes. So 5 is our number. There's 3 x's that they all share. And so I'm going to divide by 5x to the third on all of those to see what I need to multiply by to get this original answer after I divide that out. So 5 goes into 24 times, and I've got 6 x's left over. 5 goes into 15 3 times. It's a negative, so it stays negative, and I've got 2 x's left over. The x's cancel on that one, and we just get a 6. Last problem. Thank you guys for paying attention so long. These are kind of long problems, huh? Well, there's just a lot of them. So last one, I'm going to look at the smallest number. Can that go into all of them? Yes, it can. So 3 is my number. And then I'm going to look at the smallest number of x's because that's the most that I can pull away from all of them exactly the same. So I'm going to divide by 3x squared in all of these ones. And so we just need to see what's left. 9 divided by 3 is 3. If I had 7 x's and I take 2 of them out, I've got 5 of them left. -3 divided by +3 would be -1. But again, we don't have to write the 1 because we still have something left there. I had 4 x's. I'm taking 2 of them out. So I just have 2 x's left. And then I have 18 divided by 3, which is 6. And the x squareds cancel. So that is my final answer for the 11.1 review.